right, and then here is today's. What I'm going to do is go through some slides on here, then I'm actually going to pull up some problems off the assignment. So here's what we're looking at today. Polynomial and rational functions. No, that's not what I want. All right, so display setting. Let's see.
We can't hear you.
Oh, sorry. Y'all got me now. Sorry about that. All right. I'm trying to see if I can get rid of this presentation mode. Let me see if it will. That does not show up there. So let me do something a little bit different. All right, we're just going to look at it like this. All right, so we're going to look at graphs of rational functions. All right, there'll be some sketching. Basically, on the assignment, you will be picking out the proper graph. So your calculator is going to help you there to double check. But we're also going to talk about finding x and y, or x-intercepts, y-intercepts, vertical, horizontal asymptotes, diagonal asymptotes. And they call it a slant. Instead of diagonal, it's called a slant asymptote. But it's the same thing. It's a slanted imaginary line that the graph approaches and approaches and approaches, but never does touch. So let's see what they have to say here. All right, so the guidelines for graphing rational functions, where we have n of x over d of x. So n's a polynomial, d of x is a polynomial. One thing we didn't do last time, I don't think, is we're going to try to simplify the function if possible, which means we're going to factor the numerator, factor the denominator, and then see if there's any factors that will cancel to make our function easier or simpler. We do have to list restrictions on the domain before you cancel everything, so you got to make sure you do that. We're going to find and plot the y-intercept where it crosses the y-axis. We're going to find zeros of the numerator. This would be places that are where it crosses the x-axis. We're going to find zeros of the denominator. This is going to be places that are breaks in the graph, vertical asymptotes, or corresponding holes. Let's see if there's more to this. All right. We're going to find and sketch any other asymptotes of the graph using the dashed lines. Plot at least 1 point between and 1 point beyond each x-intercept. So we're going to find the x-intercept, and then we're going to find the point that's immediately before that and immediately after that to make a better idea of what the graph is. Most of the time, you're going to be using your calculator to look at that stuff, but still. And then we're going to complete the graph by using smooth curves. So here's where we start. If we want to graph 3 over x minus 2 by hand. Okay, so here's the things they're wanting you to do, and here's the things you're going to be asked to do on the assignment, and we'll look at an example, a couple problems in a minute. Is number one, you're going to be asked to find the y-intercept. Okay, the y-intercept, that is, you get the y-intercept, right, when x equals 0. So when I substitute 0 in for x, So if I find g of 0, that's going to be the y-intercept. So basically that's going to be 3 over 0 minus 2, which is negative 3 halves. And that's where they get that right there. So if I'm graphing, then that's one point that I can graph. At 0, negative 3 halves, which would be right there, that's a point that's on this graph. Okay? So I know it crosses the y-axis at that point. All right, x-intercepts would be what would cause, if I replace the g of x with 0, x-intercepts come from whenever 0 equals 3 over x minus 2. What would cause that to be equal to 0? Well, since there's no variable in the numerator, we can't ever get that fraction to be equal to 0. So there are no x-intercepts. So this never crosses the x-axis, right? Vertical asymptote. Remember, the vertical asymptotes come by what causes the denominator to be equal to 0. In this case, 2, x equals 2 would cause the denominator to be 0. So that means if I'm looking at the graph, this is an asymptote right here, a vertical asymptote. That means the graph does not cross it. All right, it may start again on the other side. Horizontal asymptote. From last time, the degree on top is smaller than the degree on bottom. So that means there is a horizontal asymptote at y equals 0, which is the x axis. Okay. Now, from there, what they're asking us to do, and the next screen should show a little bit of what the graph's going to look like. I got to go back to the mouse, and I've got to clear off these drawings. All right. So by plotting the intercepts, so that's what they did right here. You can see the intercept, the y-intercept, that's the only one we have. But we do know we have two asymptotes that they approach but don't cross. All right. And then notice what they did is they graphed a few additional points. So we knew when x is 0, it was here. So what they did is they found negative 4. They plugged in negative 4 and got negative 0.5 so that they could plot this point down here. Let me see if I can try a different color. That's where they got that point. All right. Then they also plugged in positive 1 to get this point down here. And so they got the idea. Once they plotted these 3 points and they knew these two asymptotes, then they were able to make this graph must look something like this. And then we know it's undefined here. So then they picked 2 points to the right of the vertical asymptote. They picked 3 and got the point 3. They picked 5 and got the point 1. And because we know the x-axis is a horizontal asymptote, this is a vertical asymptote, this is how they were able to determine that the graph has got to do something like that up here. Okay? So what they're doing is they are finding the y-intercept by substituting 0 in for x into the original function. They're finding x-intercepts by looking at the numerator and what would cause the numerator to be 0. They're finding asymptotes by using the methods that we found in a previous section. And then once they get those, then they're just picking a couple of points extra that's to the side or the next point's over that would give us an idea of what the graph looks like. All right. And these are always going to be smooth curves. They're not going to be jagged and things like that. All right. Let's see what we've got next. All right, so let's talk about where we get a slant asymptote from. All right, so we're just considering a rational function whose denominator is of degree 1 or greater. If the degree of the numerator is exactly 1 more than the degree of the denominator, then the graph of the function has a slant or oblique asymptote. So what does that mean? So if I have my function f of x, all right, and the degree of the numerator, so let's say the degree of the numerator is x to the third, is exactly one more than the degree of the denominator. So that means the denominator would have to be a degree 2. All right? If there's more than one difference between the numerator and the denominator, then there's no asymptote at all there. No slant asymptote. All right? And remember, for our horizontal asymptotes, the degrees have to be the same or the degree has to be bigger on bottom. So we get a slant asymptote if the degree on top is 1 bigger than the degree on bottom. All right, so it could be like that. It could be something that looks like this. 3x squared minus 5x plus 2 over x minus 5. All right, this one is going to have a slant asymptote. All right. Now, what is the asymptote? How do we determine what that is? All right, so for example, here they have a degree 2 on top, a degree 1 on bottom. So there's a slant asymptote. All right. And to find the equation of the slant asymptote, you have to use long division. So basically, we've got to divide the bottom into the top. All right, so that's what I'm going to do. I've got x squared minus x, and then I'm going to divide that by x plus 1. All right, and I'm going to go ahead and add a 0 into that so that it all counts down the way I want. So we got to go back to our long division. That's building on top of each other. If you didn't do the long division, you'll be stuck here. So x times what would be x squared? That would be x times x. That would be x squared plus x. All right. Then remember, we subtract, so I'm going to change the sign of both. That goes away, and I would have negative 2x left over. Plus 0. X times what is negative 2x? That would be negative 2. And then I would have negative 2x. What's that? Minus 2. And then when I change the, let's see if I can go down a little bit. Oh, I can't move that. All right. And then when I subtract that, I change the signs. That becomes plus. That becomes plus. That cancels, and I'm left with a remainder of 2, which means that would be 2 over x plus 1. All right. This part right here, before you have the remainder, I set that equal to y, and that is my slant asymptote. That's in slope-intercept form of my slant asymptote. All right? X minus 2. That means it has a y-intercept of negative 2, and it has a slope of up 1 over 1. And that's where they're getting this dotted line right here. So what that means is that's just like horizontal and vertical asymptotes. The graph will approach that point but never cross over it. So in the end, it looks like it's running right beside it, but it's actually getting closer and closer and closer. It just is so small you can't tell after a certain amount. Okay, so that's how we get a slant asymptote. The top is 1 degree more than the bottom. Then you do long division, and the part that is left up here while ignoring the remainder, that's the equation of the line. That is our slant asymptote. Okay, so let me clear this off. And that's the one we're on. All right, so that's what we just did. All right, so that's how we get to our slant asymptote. Now let's look. Let's see. All right, they want us to sketch the graph of x squared minus x minus 2 over x minus 1. All right. So what we're wanting to do, and this is what they're going to be asking you for, is they want you to find the y-intercept. They want you to find x-intercepts. They want you to find all the asymptotes. All right. And then you're going to pick out the graph from whatever selection on the assignment. So let's step through all this. All right. First off, if I want to find the y-intercept, all right, I find that by plugging 0 in for x, right? So that would be 0 squared minus 0 minus 2 over 0 minus 1. And that is negative 2 over negative 1, which is 2. So my y-intercept is at 0, 2. So if I was looking at this graph over here, I know at 0, 2, there is a y-intercept. All right. Now, what about my x-intercepts, if there are any? Well, I get x-intercepts by setting my numerator equal to 0. So if I have x squared minus x minus 2 equals 0, and that's what they did there. You notice they factored it, so I've got to factor that. What will multiply to negative 2 and add to negative 1 would be negative 2 plus 1 equals 0. Then I set each one equals to 0. And I get x equals 2 and x equals negative 1. So my x-intercepts are at 2, 0 and negative 1, 0. All right, so I go to 1, 2. That crosses the x-axis right there, and I know it crosses the x-axis right there. All right. Now we got to look for asymptotes. All right. And notice real quick right here, nothing will cancel once I did this. So if this were both x minus 1 and x minus 1 and they canceled, that's where I would get a hole in the graph rather than the asymptote. But we'll look at that in a minute. All right. So we get vertical asymptotes by what causes the denominator to be equal to 0. So the denominator is x minus 1. So a vertical asymptote is going to be when x equals positive 1, right? 1 minus 1 would be 0. So at x equals positive 1, and I'm going to change the color of this. My asymptotes. So there's going to be an asymptote right there. All right. Now, is there any horizontal asymptotes or slant asymptote? That's all determined by the degree. All right. This one, the top is 1 degree bigger than the bottom. All right. So whenever the top is bigger than the bottom in degree, there is no horizontal asymptotes. But if it's 1 degree more, that means there is a slant asymptote. So what do we have to do? Is we have to, let me erase some of this. Eraser. Oh, that's not erasing. All right. So what I've got to do is I've got to do long division. And I've got to do, I'm trying to find somewhere on here to write. I'm running out of room. X squared minus x minus 2 divided by x minus 1. So x times what is x squared? That's x. And that would be x squared minus x. Change the signs. I have 0x minus 2. And then x times what would be 0x? That would be plus 0. That would be 0x minus 0. Change the signs. I get a remainder of negative 1, but the remainder doesn't matter. So here, x plus 0, y equals x plus 0. I'm just going to put y equals x. That is my slant asymptote, which means the y-intercept is 0. The slope is up 1 over 1. So it is basically this one right here. Now, probably the easiest thing we're going to have on our assignments to do from here is to now go ahead and type this in your calculator to see what the graph looks like, and you can draw it in. What they're suggesting you do if you don't have a calculator is I would like pick a point back here and see what's happening. But probably what's happening is, let me change colors, is we've got this right here that's going up to that asymptote, and it's going down to the slant asymptote. And then here we have an X, it looks like it's going to go down through here, then probably up like that right there is probably what ends up happening. And I'm going to suggest using your calculator for the final drawings rather than picking out points. And let me type it in real quick just to see. We've got x squared minus x minus 2 over x minus 1. Whoops. And if you got your calculator handy or whatever, that is exactly what it kind of does look like. Okay. So that's sort of what's going on here. Let's see. Is there another problem? Okay, so now what I want to do is I want to pull up a couple of problems off our assignment so we can compare. All right, so question 1 on the assignment, it just wants to know, does it have a slant asymptote? Notice that right there. It's a little tough to see. But yeah, it's going to have one because the degree of the top's 1 degree more than the bottom one. Okay. Using long division, you find that it equals there. So what is the slant asymptote? So remember, the slant asymptote is once I do long division, here's the answer from long division. I ignore the remainder, and it becomes y equals that right there. All right, so that's what's going to go there. They've already got the y equals for you. All right. Let's see. Oops. All right. All right, so here, the rest of them are pretty much going to be sketching the graphs. That one, it just wants you to sketch the graph. You can type it in your calculator, but I can probably get pretty close. Number one, on this right here, I know that there has to be an asymptote at -6, right? X equals -6, because that causes the denominator to be 0. So I know that's not at here's -6, so the asymptote's got to be over here. This one looks like that would be correct. This one is at +6. This one is at +1. So I would know that my answer is this one right here, just solely based on where the vertical asymptote is, because this right here tells me -6 would cause that to be denominator to be 0, which means there has to be a vertical asymptote there at -6. Okay. Let's go on to the next one. All right, what's it say down here? Let's see. Want you to tell how it shifts off of our parent function of 1 over x. So you could just type in 1 over x in your calculator along with that and see how it does shift, which it should be when you add 2, or was it subtract 2 out here? Whenever you subtract 2 to it, that shifts it, what? I can't remember. Down 2. Yeah, it looks like it shifts it down 2, and the +6 on bottom there shifts it. Whenever you add a number to the variable, it shifts it the opposite direction, left and right. All right, so remember when we add or subtract to the function value, that moves it up or down, exactly how it looks. In that case, -2 moves it down. Then whenever I add a number to the variable, that moves it left or right, opposite of what you're adding to it. So that's just a quick reminder. That one looks pretty. I think we can handle that. All right, so let's go through this problem here and sort of go through. We'll do this one and one more. All right, so it says, consider the following, sketch the graph of the rational function by hand. Obviously, we can use our calculators. Number one thing I can notice real quick is where is there going to be a vertical asymptote? Right here, I look at the bottom. 1 minus what would be 0, and that would be 1. So I know there's a vertical asymptote at x equals 1. So if I look at my graphs, both of those have asymptotes at x equals 1. Looks like they all three do. So I'm going to have to do more than that. But my answer down here at the bottom, the vertical asymptote, that's what's going to go right there. X equals 1 right down there. All right. Notice it wants me to find x-intercept, y-intercept, vertical asymptote, horizontal asymptote, and check for holes. Holes come when you factor the top and the bottom, and one of the factors cancels away. And in fact, here, neither one of these will factor, so there's not going to be any holes. Okay? So x-intercept, or let's do y-intercept. Y-intercept is when I plug in 0 for x, right? So that would be 1 minus 0 over 1 minus 0, which is 1 over 1, which is 1. So I have a y-intercept at 1, 0. All right. So I know it crosses the y-axis at 1, 0. So I know that first graph is now wrong. I know that second graph is wrong. I know that third graph is wrong. Now I know it is the fourth graph because that's the only one that's crossing the y-axis at 0. All right. Then down here, y-intercept, I'm going to put 1, 0. To find the x-intercept, all right, remember we just take the numerator and set it equal to 0 and solve it. So I'd subtract 1 and divide by -3, and I'm going to get x equals 1/3. Right? That's actually, I did that wrong. That should be 0, 1. Sorry. The y-intercept is 0, 1. The x-intercept would be 1/3, comma 0. So that's what I would go to. I would go down here. And my x-intercept, I'm going to put in 1/3, 0. Vertical asymptote, that's what we did first already. Horizontal asymptote, the degree, right? The degree is the same. It's a degree 1 over a degree 1, which means you take the coefficients of the lead coefficient, which these aren't in proper order. The lead coefficient is with the x. So this horizontal asymptote is going to be -3 over -1, which means there is a horizontal asymptote at what? Y equals 3, which if we double check with our graph that we said was correct, y equals 3, right there is the horizontal asymptote. So right there, horizontal asymptote, I'm going to put y equals 3, check for holes, does not exist. There are no holes. Okay? So that's how we're going to step through that. Let me see if I can find one that does have holes. All right, that one. was almost just like it. That one does not have holes. Doesn't look like any of them have holes. Yeah, it doesn't look like any of these are going to have holes. But like I said, you would get a hole if when you factored it, the factors canceled. It's still a break in the graph, but that factor that you cancel, let's say it was x minus 1 on top and x minus 1 on bottom, they would cancel away when you were simplifying. That represents a hole in the graph at wherever x equals 1. If it's x minus 1, it would be at x equals 1. All right, let's work through this one. And all right, so what they want is they want the x-intercept, the y-intercept, asymptotes, all asymptotes, and the check for a hole. All right, so let's first do our y-intercept. That is when we plug in 0 for x. So that's going to be 3 times 0, which is 0, over 0 plus 0 minus 2, which is 0 over negative 2, which is 0. So that means that 0, 0 is a y-intercept. That's also going to be an x-intercept in this case, but y-intercept is at 0, 0. So we would fill that in. X-intercept, remember we get our x-intercept by taking the numerator and setting it equal to 0. I divide by 3 and I get x equals 0. So I have an x-intercept at 0 also. So when I'm down here filling in my answers, x-intercepts at 0, 0, y-intercepts at 0, 0. Now, what about asymptotes? All right, let's look at the denominator. X squared plus x minus 2. Let's see if it will factor. What will multiply to negative 2 and add to positive 1? That would be positive 2 and negative 1. All right, so what are the two numbers that would cause a problem if that's the denominator? X could not equal negative 2 or positive 1. So those are my vertical asymptotes at x equals negative 2 and x equals positive 1. So when I go down here, vertical asymptote, x equals negative 2, x equals 1. Now I can start glancing at my graph. Which graph has an x and y intercept at 0, 0? Not the first one, not the second one. The last two both cross at 0, 0. All right, let me check my vertical asymptotes. X equals negative 2, negative 2, positive 1, positive 1. All right, looks like both of those have the same asymptotes. All right. Now, what about a horizontal asymptote? Well, what is it? If the top one is one less than the bottom one, then we have a horizontal asymptote at the coefficients, right? If the degree is the same on top and bottom, then the horizontal asymptote is 0. I believe I'm getting that right. No. If they're the same, you take the coefficients. If the top one is less than the bottom one, then you take it is at 0. So on a horizontal asymptote, if the degree on top is the same as the degree on bottom, you take the lead coefficients to create the asymptote. If the degree on top is smaller than the degree on bottom, then the asymptote, the vertical asymptote, is at 0. So my vertical asymptote is y equals 0. Okay? Which both of these graphs have an asymptote at 0. The easiest way to tell which one of these graphs would be true is if I substitute in x equals 1, well, I would go out here 1, 2, 3, 4, 5. If I substitute in x equals 5, this one would give me a positive. This one, it would give me a negative, if that makes sense. So if I plugged in 5, and of course, you could just type it in your calculator and compare. But if I put in f of 5, that would be 15 over 25 plus 5 minus 2, which is 15 over 28, which is a positive number. So what I know is this one has to be the proper graph right here. Because this one, when I plug in 5, gave me a negative. This one gives me a positive. All right. But there we go. We've answered the x-intercept, the y-intercept, vertical asymptote, horizontal asymptote. There are no holes. That's basically how all of these are worked through. And it doesn't ask, I don't even see any that have any slant asymptotes. They're all vertical and horizontal. So there's one. That one there. Yep. That number 11 will have a slant asymptote. So you've got to divide the bottom and the top. Now, when you are dividing, notice they've got it written backwards. So what I would do is I would rewrite that as negative x squared plus 4. And then when I divide it out, I think we can divide. I'm going to put 0x to hold a place. And then I'm going to divide that by x. And so that would be negative x squared. Change the sign. That would be 0. I drop down 0x. X times 0 would be 0x. I subtract. I drop down the last one. I get 4. That's my remainder. So I put 0. So my remainder would be 4 that I don't have to. So right there, y equals negative x plus 0. Y equals negative x is my slant asymptote. All right. For that one. So don't get confused because it's written backwards. You want to rearrange it before you divide it out. And that's pretty much it. You've sort of seen there what all the problems are. So let's see. Let me stop sharing there.